Today we are going to be looking at trigonometry and area. So we want to find the area of a regular pentagon with a radius of 9 meters. So we know that a radius goes from the center to the vertex of our pentagon. So each of these radii are 9 meters long. So in order to begin, first of all, we want to find our degrees. So in this, we're going to say, well, 360, we have 5 sides, so we're going to divide it by 5. So each angle in here is 72 degrees. I'm going to leave that one blank for a second. So if each of those are 72, and we draw our perpendicular line, the apothem divides that angle in half. So 72 divided by 2 is 36. So we know that each of these individual angles in here are 36 degrees. So in order to find the area of this figure, the area formula is area equals 1/2 times your apothem times by your perimeter. So we first need to find the apothem as well as finding our perimeter. So our apothem is A. So if we take a look and we pull out our triangle that we have, and pull out this one right here, we're going to have that this is our apothem, this is 36, and that's 9. So if we want to find what A is, we can use, this is our adjacent and this is our hypotenuse. So we can say cosine of 36 equals our adjacent side over our hypotenuse, which is 9. So when we multiply this out, so 9 times the cosine of 36, our apothem is going to be 7.28. So we already know what our A is. So now we have to find our perimeter. So to find the perimeter, we need to find out what this distance here is of that triangle. So now we're using the opposite in the hypotenuse. So we're going to want to use sine. So sine of 36 equals the opposite, which is x, over our hypotenuse, which is 9. So when we cross multiply 9 times the sine of 36, that length of x will be 5.29. So that means this side length is 5.29. So this one, since it's perpendicular bisector, we know that this side is also. So we know the whole side length is 10 and 58/100ths. So each side length is 10 and 58/100ths. So if we multiply that by 5, we can get the whole perimeter. And the whole perimeter is going to be 52.9. So we can plug that into our formula. 1/2 times 7 and 28/100ths times by 52 and 9/10. We have an area which will be 192 and 56/100ths meters squared. So let's find the area of a regular heptagon with a side of 4. So if we have a side of 4, we know that each of these sides have a side length of 4 centimeters. So that means our perimeter, heptagon has 7 sides, so 7 sides times by each one's 4. We have a perimeter of 28. So if we wrote out our formula, area equals 1/2 times our apothem times the perimeter, we already know what the perimeter will be, so we have to find our apothem. So if we take a look and we draw in our radius, it's going to split. Oh, that's not the best. So if we have 7 sides, we need to figure out how much each degree is. So 360 divided by 7, so 51.4. So each of these in here is 51.4 degrees. So if we want to figure out what the apothem is, that means we are finding the perpendicular bisector. There's our A, so 51.4, if we divide that by 2, we're going to get 25.7. So in here is 25 and 7/10. So if I pull out this triangle, we have that in here is 25 and 7/10. That's our apothem. And then we know, since the whole length is 4, we know that this chunk, since it's bisected, is 2. So here we have our opposite and we have adjacent. So we're going to be using tangent of 25 and 7/10. And that equals our opposite, which is 2 over a. So in this case, we're going to be dividing, so 2 divided by 25.7. Our apothem will be 4 16/100. So we can plug that in for our a. So when we multiply this out, our area is going to be 232 96 centimeters squared. So let's find the area of a regular octagon, which has a perimeter of 48. So we already know for our formula the perimeter right off the bat. So we don't have to find anything for that. It's already there. So if the perimeter is 48 and we have 8 sides, that means each side length has a side length of 6, because 6 times 8 is 48. So if we draw in, I'm not going to draw them all in, but our degree we will be working with, if we have 360 degrees and we divide that by the side lengths of 8, each one is 45 degrees. So that means when we divide it by 2, we're going to end up with 22.5 degrees. So if we pull out that triangle, this is 22 and 5/10 degrees. This is our apothem that we don't know. And then this segment down here of our triangle is going to be 3, because the whole side length is 6, so half of it is 3. So once again, we know our opposite side and we know our adjacent. So we're going to be working with the tangent of 22 and 5/10. And that's going to equal our opposite, which is 3, over adjacent, which is a. So if we divide 3 divided by a tangent of 22.5, our apothem is 7.24. So we can plug that into our formula. So 1/2 times 7 and 24/100 times by 48. Our area equals 101 and 36/100 centimeters squared. So let's look at one more example. We want to find the area of the equilateral triangle with a radius of 5. So we have that each radius is 5. We don't know the apothem and we don't know our side length. So if we pull out that triangle, we have 5. Our apothem we don't know. Let's find our degree. So we have 360 degrees and 3 sides. So that means each one is 120 degrees. So each of these, when they're bisected, is 60. So we have 60 degrees. So to find this, we know our adjacent and we know our hypotenuse. So we can use the cosine of 60 equals adjacent over our hypotenuse, which is 5. So 5 times the cosine of 60, our apothem is going to equal 2.5. So the last thing we need to find is our perimeter. So in order to find the perimeter, we need to find out what each side length is. So if we find this little segment, x, so we're going to use sine of 60 equals x over 5, our hypotenuse. Sine times 5, x will equal 4 33/100. So 4 33/100 twice. So we get each side length is 8 66/100. Since there's 3 sides, we're going to multiply that by 3. So that means our perimeter is 25 98/100. So then our last step would just be multiply 1/2 times 2 5/10 times by 25 98/100. we get 32 and 48 hundredths inches squared.